Hi guys, welcome back to our discussion. The last time we discussed the conductivity pH simulation or pH simulator. Now we do the conductivity simulator. So again, from the list from the table, we just click the conductivity simulator and it will appear this one, and then you click this link to the to have our simulator in conductivity. So measurement of conductivity, level 1, that is measurement. So in here we have this figure, like we have this negative charge, we have this negative terminal, we have this positive terminal. So our negative is going here, our positive is going here. So this is the this will excite the two charges, creating a current, and that current will be measured. Yes, and then for sample, we have this one. The control panel, we have sample, concentration, cell constant, specific conductance at 25 degrees Celsius. Now we select this one, we click this one, and it will appear. We have choices here: HCl, KCl, H2SO4, NaCl, NaOH. If we select HCl, this will appear. This will change. Select this one. Then, as our concentration, if we select concentration at let's say 10%, 10%, and so our cell constant is 1. So our specific conductance at 25 degrees Celsius is unknown for a Siemens. Like we have to calculate this one. How do we calculate this one? By using this one formula. So you just have to click this one, the formula, and it will appear this. So the formula is specific conductance at 25 degrees Celsius is equal to 1000 C A sub 0, your A sub 0 times 1 minus A, how do you read this one? Plus BC Siemens. So our A sub 0 and A, B are constant. For details, refer to theory tab. So the one that we showed in our previous uh, video in the theory. So yung sa pinakababa, yan yung mga values niya. Then the C normality, that C is the normality. When we talk about normality, that is parts per million concentration times the density divided by 1000 times the equivalent weight. So by using that equation, we would be able to answer this unknown Siemens. So the HCl at 10% degree at 10% concentration, we would get 1.79. That is 1.79. So we just have to click this one. Hope it's correct. And if it is correct, it will appear here correct, and it will turn to green. Then you cannot click this one kasi hindi pa tapos. How about if we change this one to 5%, and at 5% naman, what would be our Siemens? We would get 0.65. So submit, you click to submit, it will appear correct. Now if you select 5 again, then kailangan natin makabuo ng tatlo para makagraph. So after having three values of Siemens, mag-appear to, magiging green na to. Meaning pwede na siya. Tingnan ang plot natin. Sa plot natin, we have this one. From our abscissa, a coordinate, we have conductivity and Siemens. Then for the abscissa naman, we have concentration and percentage. Now, your zero, no, this one. If we increase our concentration and percentage, we also increasing our conductivity in Siemens. And as we decrease our conductivity Siemens, we also decreasing our concentration and percentage. So this is the interpretation of this graph. So close this one, then Let's proceed with the level 2. For the level 2 naman, we have this one. If we select this HCl, then at 5%, okay, 0.65, let's say you have this one, 27. What would be our Siemens at 27 degrees? At 27 degrees Celsius, we have 27 degrees Celsius, we have 0.63, right? Then as we change again our temperature, 27 or 10 degrees, as we select 10 degrees Celsius, 10 degrees Celsius, we are, the answer is, for the Siemens is 0.50. 0.50. Then as we select, this will change temperature na naman. At 44 degrees Celsius, we got um, at 44 degrees Celsius, we get 0. 0.84 of 44 degrees Celsius. Now, after calculating 3 Siemens for different temperatures, for 3 different temperatures, we now be able to see the graph. So by clicking the plot, so this one, so this is the plot, this is your plot. Now, as you can see here that this is your coordinate, your conductivity in Siemens, this is your temperature in degrees Celsius in your axis or your x-axis. As we increase our conductivity in Siemens, as we increase our temperature in degrees Celsius, we also increasing our conductivity in Siemens. And we also increasing, so meaning that the at high heat temperature, there also a big great amount of conductivity that will occur. So that is an interpretation. And then for the that is for level 1. How about for level 3? So by clicking this, we would be able to see the level 3. This is the last one. Now we have here an control each panel for HCl. Yeah, like we have this sample, this figure. This is your negative charge, this is your positive charge, this is the length between them, and assumption half of this value is deposited in each electrode. So the fault values are L, this is the length, the difference, and A is your length of this one, and then B, this one, the width. So L is 1 centimeter, A is 10 centimeter, B is 0.1 cm. Selected contamination is 0.1. Okay, for this level 3 contamination, if we have the sample HCl, then this window 5, window 5, concentration 5, select contamination, we have select 1 mm, this is 1.79. So this is the sa level 3 concentration. So if we select the 1 mm, so it will give us a modified constant which is 0.90, then specific conductance at 25 degrees Celsius, ito yun, 1.79. Ang modified specific conductance value natin is 0.59. So again, if we select 2 mm, what would be our this one value? So it would appear that just like this one. So may changing sa. So 0.2 modified constant natin at 2 mm. Modified specific conductance value is 0.53. How about if you select this 3.5 m? It would give us 0.49 modified specific conductance. as value. How about if you select this 4 mm, they will be 0.45, and if you select 0.55, it will be 0.41. Meaning, in conclusion, if we decrease the temperature, no, if we increase the temperature, no, the millimeter of our contamination, we are also decreasing our modified specific conductance value. So that is the what happens here. As you decrease, as you increase your contamination in terms of millimeter, you are increasing contamination in millimeter. You are also decreasing your modified constant conductance value. So that's it. That's all for this conductivity simulator, guys. So for conductivity sa conductance simulator. So see you next time. Bye.